Yes, okay, so my name is Ainamani to present this project with Shema Collins, self-driving cars. So the problem is human car driving. As I say here, it might not necessarily be a problem, but it can be improved to eliminate some of the problems it brings about. Because people driving cars brings about many problems, which we would like to reduce or eliminate completely by introducing self-driving cars. These cars will drive themselves without any human interference, so we wouldn't need drivers and the expenses that come with that, such as driving permits, problems such as accidents, drinking and driving. So all that can be eliminated by introducing self-driving cars. So we use a data set. Uh, so here is how the data set we obtained would help address our problem. So we will use images. Our data set contains images, so we will use those images to train our AI about certain road features such as corners. So it will know that this is a corner, I need to take a corner here. Junctions, which side of the road the car should be on, because it should know whether to drive on the left or the right. And traffic lights, it should know how traffic lights look like and what, yeah, what exactly they look like. So another thing, we use a manual. There is a manual, a guide, a PDF, a guide in our set that that will help us know exactly what to do, when to do it, and where to do it. Because we might not exactly have that knowledge yet to, to do exactly what we're supposed to do, the exact time, and the exact place. So we need the manual to help us know what we are doing, to know what we need to do, when to do it, and where to do it. So there is also a requirements list. There's also a requirements list in the data set, and that will help us know what we need for this AI to be created and to work efficiently. Yeah, so the factors that we considered before selecting this data set, yeah, first and foremost, it contains the manual, like I said. So yeah, that really makes it easy for us because we need the guide, because at the moment we don't really know what to do exactly. So we need the guide. So with that manual, it will guide us. So yeah, that's a very big factor. And it was available. It was open. It's an open data set, and it wasn't heavy. It was something about 20 something MBs. So it wasn't really heavy, and that also made it easy for us to get. So another thing was it's complete. It consists of almost everything that we need from a data set at the moment. So that's also a big factor that we considered before selecting this particular data set. And all the files included in the data set are easily readable and they are reliable. We would like to think they are reliable. So the important features in our data set include it consists of images. Yeah, these will use these images to train our AI to show it road signs, for example, the zebra crossing, um, traffic lights, all those, because it doesn't, as you're creating it, it doesn't really know how these things look like. So these images will help us to train it. If we show it images of zebra crossing, it will know that when you reach and you see something that looks like this, you stop and wait for people to pass. So this will just help us train it well. And also, as I said, there is some code, pre-written code. There is some code, and yeah, this will also helps us reduce our coding work and time. It helps us to save time because this particular code might have taken most of our time, maybe, or it have been hard for us. So it really helped us that there was some pre-written code and it would be easily used and added to our own to make it efficient. Also, the data set contains of the manual, the PDF that would guide us, would lead us to know what we are doing, when to do it, how to do it, exactly where to do it. So we won't really face a lot of challenges with that guide, because if we face a problem, we go to the guide and figure it out. So those are the important features that in our data set. So I would like to call upon Shema to explain the Bayesian theorem and some other stuff. Shema.
Good evening. I'm Shema Collins alongside Inamani Douglas. We're working both on the human car driving AI project. And as I said, I've explained a little bit of the data set and mainly about the problem we are solving. So furthermore, I will explain the Bayesian theorem, the naive Bayes theorem, and the Bayesian networks. So, what is Bayesian theorem? The Bayesian theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. So this can be stated in our formula as we see it here, where probability of A over B is a conditional probability where the probability of A occurring given that B is true. So for A to occur, the condition B should be true. For example, if somebody is to say that you're sick, you you have to first show some symptoms, and these symptoms can be condition B, and the sickness is probability A. So probability of B over A is also a condition probability where the probability of B occurring given that A is true. This is also vice versa of probability of A over B, meaning that the condition A should occurs when condition A is true. Then probability A and probability B are probabilities of observing A and B respectively without a given condition. Then the naive Bayes theorem, these are more of classifiers. So the naive Bayes classifiers are a collection of classification algorithms based on the Bayes theorem. But what stands out about the naive Bayes theorem is the fundamental naive Bayes assumption is that each feature makes an independent and equal contribution to the outcome. So each feature involved in the classifier, the naive Bayes classifier, works independently and does not depend on the other, like we have seen the Bayes theorem. Though we should take note that the assumptions made by the naive Bayes classifiers are not generally correct in the real world situations. So it's not advisable to use the naive Bayes classifiers in real world situations. Moving forward, we have the Bayesian networks. These networks are graphical representations of the different probabilistic relationships among random variables in a particular set. This is a diagram that I'll use as an example for explaining the Bayesian networks. We have the nodes burglar, fire, which are parent nodes to the node alarm, and the alarm is a parent node to call Shema and call Dyson. So explaining this more, we have an alarm node which rings upon two probabilities, i.e. burglar and fire, which are parent nodes of the alarm node. So for the alarm node to ring, burglar and fire nodes should first occur. So the alarm node is also a parent node to two probabilities, call Shema and call Dyson. Once a scenario of a fire or a burglar action takes place, the call Shema or call Dyson nodes are executed. This is basically the Bayesian networks. Moving forward, we can state the difference between the Bayes theorem and the naive Bayes. So the main difference between these two theorems is the naive Bayes theorem assumes conditional independence, whereas the Bayes theorem does not. This means that the relationship between all input features are independent. Like we said earlier in the naive Bayes theorem, all features are independent and have equal participation in the outcome. Whereas the Bayes theorem have conditional probabilities for each feature to take place. Going on, we are also asked to differentiate between the naive Bayes and the Bayesian networks. With the naive Bayes theorem, features make an independent and equal contribution to outcome, while the Bayesian networks variables have different probabilistic relationships in a particular set. The naive Bayes, as we had talked about it looks at variables and features as independent nodes that work alone, but all of them have a contribution to the outcome. While the Bayesian networks have probabilistic relationships such that one node should occur for the other node to also occur. So that's the difference between the naive Bayes and Bayesian theorem, and that was all about our project, and we use different references such as the Java 3 points, gigs for gigs, and for our data set we got it from cargo.com, and for those who might need more about datasets, we got them from datasetsearch.google.research.com. So this can basically help you get datasets from Google, and it can also help you build your own AI model, and this can be a good source for datasets. Thank you. That was a presentation from me, and Shema Collins, and I normally Douglas Wagambe. Thank you for listening to us.